Welcome to the lecture on weldability of non-ferrous metals and alloys. So, we have already discussed about the weldability issues in different materials, mostly they are ferrous based. So, we talked about the steel, we talked about cast iron, we talked about alloy steels. So, we should also have the idea about the weldability of non-ferrous metals, because they are very much one of the important materials, because in many sectors we use to see, because of their inherent advantages, they are made of non-ferrous materials, and once you have the materials, then certainly you need to know the weldability behavior of these materials. So, prominently we will talk about the weldability issues in materials like aluminum, copper, magnesium. So, these materials which are mostly used because of many advantages, and we will have some idea about these welding aspects. So, first of all we will have the weldability aspects of aluminum and its alloys. As far as the properties are concerned, we know that aluminum is a silvery white material, and it is it is a light metal which has a very less density, even about 1/3 of the density is there of the steel. It has very good ductility, and also it is non-magnetic. Then it has a very good conductivity, even its conductivity is better than that of the copper. So, that is again another advantage, but then that may be challenging also when we talk about the welding aspects. So, we will talk about it, that how these properties, whether they are becoming a challenge or they are the qualities which we relish. So, that way. Then the one of the very important thing also with aluminum is that it is forming very high strength alloys with other metals. That gives this material a very high advantage, because when it is alloyed with some other materials then the strength is quite high, and with lesser density you can see it can be seen that you are getting a very good properties of the component which is made from these alloys. So, that is one thing, that most of the cases, unless you require highly ductility value or maybe very high conductivity, most of the cases we try to use the aluminum alloys. And as it has this tendency that it is able to form very high strength alloys with other metals. So, that even is another added advantage, that you are able to have the variety of alloys which can be used for the different applications. Then you have if you talk about other properties. So, if you see that it has a very high resistance to corrosion. So, I mean, as compared to many other metals, it has a very high value of resistance to corrosion, and this is because of the protection by the thin oxide film. So, that is formed on the surface itself. So, because of that it has a very high resistance to corrosion. Then the fusion range is basically between 520 to 650 degrees centigrade, and melting point is that is close to 670 degrees centigrade. So, it is or 660 to 670 degrees centigrade. So, that is your melting point. Now, because of all these properties, so you have the intensive use of these material like the aluminum. So, that is they will be becoming they alloy with many elements like copper, chromium, then you make it with nickel, even iron, and zinc, manganese, silicon. So, with them they are making variety of materials, And many a times when you talk about the strength of these alloys, which is made by combining with other elements, they are approximately 4 times stronger than the same weight of mild steel or the iron based alloys. So that is the advantage of such material or alloys which is being developed by the aluminum with the different alloying elements. You coming to the welding characteristic of aluminum and its alloys. So, otherwise you must have the idea about where they are used. Aluminum has use in many industries, like it has because of its varying properties, it has extensive use in the different industries, like you use in the transportation industries. All these components are made by these aluminum based alloys. Then wherever you need the conductors or heat exchanger parts, so you go because of their high conductivity value, you make these parts with aluminum alloys. Then you also use in the food industries, like like in the refrigeration equipments, you have storage containers. All these things are made by aluminum. Even in the cryogenic applications, we use these aluminum parts. So that way you have extensive use of these materials. So we will talk about the welding characteristic of aluminum and its alloys. Now, what we earlier studied, that we discussed that there is a thin film oxide that is present on the surface. So this is removed chemically or mechanically before melting, because that layer that basically is a protective layer for aluminum, and that needs to be removed. So you can remove it by chemically or by mechanical means before the welding. So the and when you do the welding, then also you have rapid formation of these oxide films. So that is basically becoming a challenging job when you are doing the welding of aluminum. So what is happening, that this thin film which is formed, that may contain moisture, and it may react during the fusion welding and liberate hydrogen to form the porosities. So basically that is the main challenge, that the film which is formed, so that may contain the moisture, and then that will be once that will come in interaction with the heat, then you will have the chance of the liberation of hydrogen, and that will basically be forming the porosities. So that becomes a very challenging job. So that one you have to be you have to have eye upon this aspect, because the type of welding process which you have to be to select, it should be such that you have to take care of that oxide layer. So what you do is, normally if you go for the different means to remove that layer, and for that we are taking the methods like brushing, then scrubbing, these things we are doing before that welding. We also take suitable flux during the welding or during the brazing operations. Suitable electrodes should be used. Then normally we try to use the DCRP. So that is electrode is connected to positive terminal, and that is found to be effective for the MIG welding, and AC is used for the TIG welding. So that is normally the practice which is being followed in the case of aluminum. So what is happening, that if you take the DCRP and use it in the TIG welding, So, in that case the tungsten electrode will be very much heated. So, once you know that when you use the when you connect to the positive terminal, then 2/3 of heat is generated at the positive terminal. So, in that case your 2/3 of heat is generated at the electrode and it gets overheated, and there is no adequate melting of the metal. So, we use the AC for the welding of in case of TIG welding, and the cleaning of the oxide. Another advantage is that when you use AC, then in that case in half of the cycle the cleaning of oxide is carried out, and that is done in the positive half cycle, and in the negative half the electrode gets cooled down. So, and the base metal gets heated up. So, so that will have the chance of adequate fusion at the interface. Another thing is that since it is a very good conductor of heat, so it will be dissipating the heat at a very fast rate. That is one property which is worth looking at, because being a very good conductor, as soon as you imply the heat, or as soon as you subject the heat at that particular position, so that heat is getting transferred very quickly because of very high conductivity value. So, you have to have a proper way to control this heat loss so quickly from the joint. So, normally what you do is that we try to. So, for that what you do is you take the nozzle somewhat larger, so slightly bigger. So, mostly in the case of gas welding, or if you are using the other type of welding processes. So, especially in the arc welding, you take the current value somewhat larger. So, this is as compared to the welding of steel, and also that when you are doing the welding of thick sheets, in that case you try to preheat. So, preheat of thick sheets, because if you are doing the preheating, in that case the rate at which the heat will be transferred, that will be smaller because of the lesser temperature difference. So, that is the advantage of having these points in those cases. So, then the high coefficient of the linear expansion, so that may lead to distortion and buckling. So, that is again it has the property that it has a very high coefficient of linear expansion. So, you will have the chance of distortion and buckling if you do not take the proper care during that welding operation. So, you will have to have proper joint design, proper edge preparation, all that you have to have, and also preheating, so that this cracking may be avoided. Then prone to cracking, so because of low strength hot solidus. This is another problem, because when the temperature is high, so certainly its strength is quite low. So, it is very much prone to cracking when you have the temperature near the solidus. So, so that is why when they are welding under the restraint, then the metal is likely to crack. So, that is one that is the challenge in this case. Heat treatable alloys show greater tendency to crack. So, in the case of aluminum, especially the duralumin and all that alloys which are heat treatable, they show very much the tendency to crack. Then if you are doing the cold working, if you are doing you have the cold worked or peened work weld metal. So, that is more attacked than the annealed metal. So, especially under the severe conditions, I mean corrosive conditions. So, when you have the corrosive media, in that case when you have these peened metals are there, so in those cases they are basically more likely to be having the corrosion cracking under the corrosive atmosphere. So, that is there. Another challenge with the aluminum is that it does not show any kind of change in the color. So, now the challenge is that in the case of aluminum, it does not show any color change on heating. So, many a times when you are doing the welding and there is change in color. So, in case of iron, suppose because of the change in the color you can have the feel that what is the temperature, whereas in aluminum that is not the case. So, because of that many a times it becomes difficult to judge that when is metal beginning to melt, or when the proper welding temperature has reached. So, for that you have to have the two indicators to the welders, and these are basically that the melting of the dry flux and the blistering of the metal surface, because all these two are indicating that the proper welding temperature has reached, and then you can accordingly take the immediate measure what has to be done. Then otherwise if you look at the different temperatures, different processes which can be used for welding and its alloys. So, these are like oxy gas welding, metallic arc welding, resistance welding, carbon arc welding, you have brazing, then you have solid state welding, MIG welding, TIG welding, atomic hydrogen welding. All these processes can be used in the case of welding. So, mainly we had the privilege to know the aspects about its properties, which will tell you that what precautions you need to take while welding the aluminum because of its properties. Now, we will talk about the copper and its alloys, and we will have the information about the weldability aspect of copper and its alloys. So, as we know that copper alloys have the very characteristic properties, like they have excellent corrosion resistance, very good electrical and thermal conductivities, and also they have very high formability. Now, this high strength and corrosion resistance, this property makes them suitable for the marine applications. So, that is another advantage of copper. Then since it has very good wear resistance, high hardness and corrosion resistance, it is also used for the surfacing of the metals. They can be soldered or brazed. So, so that is these are the properties. Easily they can be polished, they can have they can be plated easily because of very high conductivity. So, all these properties are there for the copper. Now, if we talk about the welding aspects of the copper, now what you see that the copper has very high thermal conductivity, and that necessitates very high heat input into the parent metal, because we have studied that for even aluminum also because there is a very large value of thermal conductivity, will basically increase the tendency of heat to flow very readily. So, what you do is that either you preheat, or maybe that you have to use the you have to give very high heat input to the parent metal. So, because to contract that effect, because if that will be dissipated fast, that may lead to undesirable results. So, so we can have the high heat input, or you can also do the preheating. Then you have the great value, I mean large value of thermal expansion coefficient. So, that again will induce the residual stresses. So, so normally it is advisable to go for the slow welding speed or covering the welding joint with insulating material. So, that is what the advice is in the case of copper, that you go for slow welding speed or cover the welding joint with the insulating material, because if the because the thermal expansion coefficient is high. So, there will be more warpage, and because of the stresses which are generated. Then further it has the tendency to absorb the oxygen. So, what is happening, that since it has very much the tendency of absorbing oxygen. So, for avoiding that problem, what we do is we normally take suitable flux or even inert gases. So, so that is the way by which you can have the control upon this phenomena, like the oxidation of the oxidation problem related to the welding of the copper. So, so apart from that, if you look at other properties, like if you say for the copper. So, in the case of copper, the molten steel, the copper, that is is considered to be more fluid as compared to molten steel. So, you can have the use of more welding speed as compared to steel, because in this case the there will be it has the more tendency to be in the fluid state as compared to that of steel. So, this is that. Then one more property is that it has very low relative strength at something close to above 482 degrees centigrade, and so the cracking may be developed in the copper, because it has low strength at that temperature, I mean above that temperature or above close to 500 degrees centigrade or above. So, that chances of cracking are there in those cases. So, if you talk about the different welding processes which are can be used for the copper, they are TIG, MIG, gas welding, brazing, and soldering. That's they are the processes which are used for the copper welding. So, next will be next of the important alloy or the material which alloys are very much used is the magnesium alloys. The magnesium alloys have the following characteristics, like it has very high strength to weight ratio. If you look at the so it is also a silvery white material, and it has very high strength to weight ratio. So, its specific gravity is even smaller, it is even lighter than aluminum. It is only 1.74. So, that is how you can have the idea that it is how light it is. Now, all the materials, aluminum lies about 1.5%, 1.5 times, like it has something close to 2.6 or so. So, that way, and then if you look at other materials, it is even larger. So, so copper is about 5 times, or iron is about 4 times or so. So, that way what you see that it has very high strength to weight ratio, it has very good fatigue strength. So, it has also melting close to that of iron, that is 650 degrees centigrade. Then it has a very good fatigue strength. So, because of their strength to weight ratio, they are used in the aviation industries or automobile industries, where you require the sieving in the weight. Then you require it has a very good fatigue strength. So, that is one very good quality of these materials. They have very good dimensional stability in service, and also very good the damping capacity. So, of these materials, they have very high thermal conductivity, and also they have good electrical conductivity too. So, these actually make them used in many applications, like they are used for airframes, engines, then they are also used in marine applications, then they are using in missiles, engine transmission pumps. So, all these then you are for the textile machines and printing equipment. Then at many places we find the application of these alloys of magnesium that is used. If we try to discuss about the welding characteristic of magnesium alloys. So, the most of the magnesium alloys they are readily weldable, and they can be affected by the oxidation, because oxidation of the magnesium and its alloys is very rapid. So, that is when it is heated to the melting point in air, then it is readily trying to get oxidized. There may be burning, there may be fumes. So, it is considered to be that way very challenging. So, you normally try to have inert atmosphere and use suitable fluxes basically in those cases. It has very high thermal conductivity and also very good thermal expansion, and because of that you have the challenge in the welding of magnesium, because there may be large residual stresses that may be formed, that may lead to distortion of the component. So, there are precautions taken, and we take, like you go for fast welding speeds, then you have smaller welding beads that they are taken, then putting the holding the parts in the jig, and use of lower melting point, lower shrinkage welding rods. So, these are the materials we have studied, that these are the points which if you use, they will be effective in controlling the distortion. Then susceptibility to hot cracking. So, that is another challenge with the magnesium alloys. So, when especially with the magnesium aluminum zinc alloys, when you have about 1% of zinc. So, they are very much susceptible to the hot cracking, and many times these welds in these hot sort alloys. So, they should be started from the end of the seams. So, started away from the end of the seams. So, to have the control on the hot cracking. So, these are the welding aspects of the magnesium and its alloys. Apart from that, you have the grain growth and aging also, that is also observed in such materials. So, here in this case you have the chance of grain growth and aging. You have the probability of stress corrosion, and when you have you alloy it with more than 1.5% of aluminum, in those cases you have the chance of also stress corrosion. And then you have surface preparation or cleaning. Many a times you used to have, what you do is, when you do the welding, in that time the cleaning is very much, surface preparation or cleaning is basically adopted. So, that is a good welding, that is considered to be a good welding practice in the case of magnesium. So, the process which are used for magnesium alloys are like they use TIG, MIG, resistance welding, gas welding, brazing, pressure and forge welding, then electron beam welding. These are the normally used welding processes which we use in the case of magnesium alloys. So, that is basically we have got some information about the weldability aspect of the aluminum, copper and magnesium alloys. We can have the information by reading the books on other materials also. Thank you very much.